Welcome everyone to my talk on observability on Zen system, and I'm going to talk specifically about Citrix Hypervisor and Zen server, which is built on top of Zen and the XAPI project, so sort of a continuation from what Paul has been talking previously. So this is the work that we've been doing at Citrix for like the past 5 years since I started there. So it includes things that have been done by other members of the Citrix team. I'm going to start with some examples of some real bugs that we found either in production from customers or from our own testing system, try to show some how we track down the root cause for those particular bugs, and then try to think a bit more general, because there are some techniques or there are some tools that we use to fix or identify these particular bugs, but they're all very individual, they're all very specific. What can in general be done to make it easier to debug, easier to observe a system? Because in some cases, in terms of Zen server, observability is a bit of an afterthought. There are some features that you have, like you have RRDs that you can monitor various metrics. And then, of course, you can SSH into the system and debug it yourself. But the individual components and the toolstack as such doesn't really have observability or debuggability at its core. Or it's not usually part of a design. It's usually you ship a feature and then you find out, okay, there are all these problems coming in. What can we do to make them better? It might be good to preempt that, and before you deliver a feature or before you make a large change, to think about how am I going to debug it? How am I going to observe it? If there is a customer or someone having this problem in production, do I have the necessary information or tools to debug it without having to go and instrument the code and recompile and give you a patch? So we're trying to think on how to integrate observability as a design principle into the product. And sort of some inspiration for this might be that some hardware or some hardware circuit design has designed for test and designed for debugging as sort of a principle. Like if you've got a circuit, you've got this industry protocol called JTAG, where you can flip-flop and query it and give it test vectors and check how it works. But sort of in software, sort of think about that as sort of a secondary feature, even though as a developer, in my day-to-day work, I do quite a lot of debugging, quite a lot of profiling. So spending a lot of time.
You are currently the only person in this conference.
Okay. Is that good?
Yeah, let's see if it works. Yeah, thanks. Oh, these slides don't seem to be. Okay, there we go. Yeah. So we got this tool called Rage, Results and Graphing Engine, that we use to do regression testing of our product. It's a very old project, and it works by capturing first environment and configuration of everything. Then you run a test, it produces some metrics, you import it, and you can graph the results. And you can also try to group things that have run in similar conditions, like in the same guest kernel being used or the same Zen version. You usually want to compare things, and you change only one thing, that's the build under test, but you want to confirm that after the fact you run something, okay, what have I actually run? Because over time, of course, you upgrade various things, and then you can't really do an apples-to-apples comparison anymore. So this concept of a scale of measure, which is a unit together with a polarity, is sort of the same concept as you would have in phoronics, which is in fact one of the tests that we use. But still, this testing system, although we have the running of the tests automated, we don't have the processing of the tests automated. So that's still something that we can improve on in the future to make all of this fully automated, to just give it 2 builds and, okay, tell me, is it better, is it worse, how much better, how much worse. There are also some statistical methods that have been added lately, because in our testing we found that the results we get aren't usually normally distributed. Sometimes that's due to the environment not being perfect, like you've got some SSDs and they drift in speed at different rates. So you really want to accurate results, you use the same machine to reproduce things and have a lot more data. So one thing the system can tell us is also if it doesn't have enough data, and it can tell us like confidence interval, which can be pretty large. It doesn't have enough data to make any judgment, and it's based on these 3 papers on how to do these comparisons. So it can tell you, okay, can I say with 95% accuracy that my tests are 5% faster, 7% faster, 10% slower. So it gives you the largest percentage that it can accurately say, and it will also show you the results. But it's still only giving you 1 data point, right? You run your test, it gives you 1 data point. You still don't know what happened. Okay, why is it faster? Why is it slower? So we have all these metrics that we collect from our system. Wouldn't it be great to integrate all of that together? So it's sort of called active benchmarking elsewhere in the industry, so that you actually look at the system while the benchmark is running, and then you identify the bottlenecks and the metrics. So we can try to think about how to automate doing that, and it goes together. If you have an observable system, then you can do all of that. There are also some challenges with performance testing, because right now all of these security mitigations come with expected performance impact, and although we try to reduce their impact, we can't completely avoid it. One thing that would help immensely if we would have MSR archcap support and the CPID MSR leveling policy that's being worked on in Zen would be finalized, so we can start using it, because then you can avoid mitigating the same security issue twice, both in Zen and Linux. You can say, okay, I've mitigated this in Linux, and then the Linux guest would know, does it still need to do the mitigation or not? And we also used, we don't have that yet, but what we can do, we can make some data-driven decisions on what our defaults should be, which is a trade-off between security and performance. Because usually we care about protecting HVM guests. PV guests are sort of deprecated now. You can only run them in PV Shin. And really the only PV guest is mainly DOM0, which is trusted to run non-malicious things, except of course if you somehow exploited something to escape, like QEMU in DOM0. But still, like the 9 times slowdown is not really acceptable for DOM0. But we found out luckily that tweaking the spec control line so that we apply a particular mitigation only to HVM guests, but not PV guests, avoids this massive slowdown. And that's of course good to know before you release it. There are some details here on the slide on how this works and what the inputs and the outputs of Rage are. I'd like to talk a bit more about the next steps here. So I already mentioned open tracing and open metrics. So we try to add that to the code. I'll show an example a bit later on. And especially it would be useful because we run a pool with multiple servers. You start an API call on one host. It doesn't necessarily stay on that host. It usually needs to do API calls to other hosts. Even just from a debugging point of view for the developer, it's very useful to be able to see how all of these API calls flows through the system. And then, of course, we can integrate the metrics gathering and collection with other tools, with performance probes, with user space probes. We can try to stream these metrics live to some dashboard, or we can do what we did previously with our RDs. We gather them up, we aggregate them. All of this is built into the protocol. It's quite flexible because you can interpose in the protocol and do this sort of sampling and collections. This is how one API call for starting a VM would look like. You would see here the VM start and then all the other things that Savi has to do and ZenObsD has to do. You have to plug some disks, you have to activate the disk, you have to attach the disk, and how long those take individually. Right? So it's also very useful to debug things and also to just see where the bottlenecks are a bit more visually. because maybe there's a bottleneck that you weren't really expecting. And also, why are we doing the diff plug after the view deploy? Like, what's the connection? Like, the network should be able to go in parallel with the disk. Why isn't it doing that way? So, there are lots of improvements that could be done. And of course, if you have metrics, you need lower overhead of gathering them. And also you have to gather relevant metrics. So that goes back to what I presented earlier, that we're missing saturation. And there are lots of these, not quite standardized, but like suggested methods in various places, like the use method, utilization, saturation, errors, and various other methodologies that have saturation as their components. So it's good if we could review these methods and try to look at our system as a whole and try to identify what we want to plug and what's missing and what we need to add. And then, of course, all the various things that you know how to do low overhead gathering with ring buffers and sort of Zen trace can be more configured to work that way as well. Really good if we could get like some flame graphs out of this over DOM0. Can we enable tracing from the toolstack itself without you having to go there and enable metrics yourself? So there are lots of possibilities to do. All of this is still at the conceptual phase. And of grammars, again, this is all still in an idea phase. We currently use Float or D3, but we could use this more modern VegaLite-based drawing, and we can generate a schema, so we can generate that from our tooling. So it would be interesting to investigate how to do that in the future. So maybe as a conclusion, it would be really good if there was a place where we could put all of these techniques and tools. It would be good if the Zen wiki was more easily accessible. I think currently there is a 404 page that would be good to fix on the sign up. And again, there are lots of prototypes and patches here that I'll try to send to Zen Devel at some point. And well, the goal of this is just to encourage people that when you actually see something that is slow, it's a lot easier to fix it. That's easier to see. Like with these techniques, I noticed that we were spawning a process to call touch file, for example, and I mentioned that, and Tao had a pull request to replace that with a syscall within a few minutes. But if we don't have these tools, we didn't specifically go and look for them, right? If we have these tools, you can look for anomalies, you can look for easy things to fix. So there are lots more details here in the slide if you want to go through them. And yeah, happy to answer any questions. There are no questions, and thanks for your attention.